March 24, 1944, 10:30 p.m. Stalag Luft III, Nazi-occupied Poland. Squadron leader Roger Bushell stood at the entrance of Tunnel Harry, 30 feet below ground. Behind him, 220 Allied officers waited in silence. Everything was ready. The forged papers, the civilian disguises, the compasses. But there was one problem nobody could see. Over the past 11 months, they'd excavated a tunnel 336 feet long. That's longer than a football field. And here's what makes this impossible. They'd removed 200 tons of bright yellow sand from deep underground, without the Germans noticing a single grain. The Nazis had designed this camp specifically to prevent tunneling. They'd buried seismograph microphones to detect digging, built the barracks on stilts so guards could see underneath. And most clever of all, they'd chosen this location for its soil. Because beneath Stalag Luft III lay a death trap for any escape attempt. The surface was gray topsoil, but dig just 6 inches down and you hit sand so yellow it looked like mustard. Spread that sand anywhere in the compound and guards would spot it instantly. So how did 600 prisoners move 200 tons of screaming yellow evidence right under the noses of trained German intelligence officers? The answer reveals one of the most ingenious engineering operations of World War II.
To understand the scale of this challenge, you need to see the numbers. Tunnel Harry measured exactly 2 feet by 2 feet, barely wider than your shoulders. It stretched 336 feet from Hut 104 to beyond the wire, 30 feet deep, below the buried microphones. Here's the calculation that should have stopped this escape before it started. A tunnel 2 feet square, running 336 feet, produces roughly 140 cubic meters of excavated material. That's 200 tons of sand. To put that in perspective, 200 tons is the weight of 40 elephants, or 2 fully loaded semi-trucks. And that was just Tunnel Harry. The prisoners actually built 3 tunnels simultaneously – Tom, Dick, and Harry. Combined, they moved over 600 tons of sand, all while German guards conducted random inspections, all while intelligence officers called ferrets prowled the compound searching for exactly this type of activity. Squadron leader Roger Bushell, codenamed Big X, stood before the escape committee in April 1943 with a brutal reality check. "We've lost or abandoned at least 50 tunnels in this camp," he said. "Every private enterprise fails. This time we concentrate everything on 3 tunnels. 1 will succeed." Bushell had escaped captivity twice before and been recaptured both times. He knew the stakes. If caught again, the Gestapo had promised him a bullet. But he also knew something the Germans didn't understand. The Allies were losing 250,000 airmen to enemy action. Those who survived the bailout faced years, maybe forever, in captivity, unless someone fought back. Bushell's mission wasn't just escape, it was chaos. Get 200 men out in one night, force the Third Reich to deploy 70,000 troops searching for them, disrupt the war machine from inside a prison camp. But first, they had to solve an engineering problem that seemed physically impossible. The Germans had thought of everything. Seismograph microphones planted every 33 feet around the perimeter could detect a shovel striking sand from underground. Barracks elevated on stilts meant guards could walk beneath them any time. Regular hut inspections, searchlights, guard towers, roll calls twice daily, and that yellow sand. Peter Fanshawe, one of the prisoners, described it perfectly. The problem was the contrast – gray dirt on top, bright yellow sand below. Mix them together and you created a color that screamed tunneling to every guard in the compound. The Germans knew this. That's exactly why they'd built the camp here. So Bushell assembled his team and asked them the question that would define the next 11 months. How do we make 200 tons of yellow sand disappear?
The solution came from careful observation and desperate innovation. The prisoners studied the compound like engineers analyzing a manufacturing plant. They needed dispersal points, places where they could dump yellow sand without it being noticed. Gardens. Perfect. The prisoners had been allowed to plant small vegetable gardens throughout the compound. Turn the soil, mix in yellow sand, rake it smooth. But gardens could only absorb so much before the color changed too noticeably. The theater. When the Germans allowed POWs to build a theater for entertainment, the prisoners saw opportunity. Seats were built on a raised platform. Underneath, a hollow space. They could store hundreds of pounds of sand beneath those seats, hidden in the darkness. But these solutions combined couldn't handle 200 tons. They needed something else. That's when they invented the penguins. The name came from how the men walked. Picture this. A prisoner would visit the tunnel entrance hidden beneath the stove in Hut 104. Below ground, diggers filled long cloth bags, made from stolen long underwear and pajamas, with yellow sand. The bags had drawstrings at the top. The prisoner hung these bags inside his trouser legs, tied to strings around his neck and threaded through his pockets. Each bag held about 5 pounds of sand. Then he'd walk out into the compound. Here's where the engineering brilliance shows. The prisoners didn't dump the sand. They dispersed it. They joined groups gathering near the vegetable gardens. Casual conversations. 30 men standing around talking about the weather, about food, about news from home. And while talking, they'd pull the strings in their pockets. The bags opened at the bottom, releasing sand down the inside of their trouser legs. It trickled out onto their shoes and onto the ground. Then came phase 2. Other prisoners with rakes would immediately turn the topsoil, mixing the yellow sand into the gray dirt. Within seconds, the evidence disappeared into the ground. They called these men penguins because they waddled when they walked, trying to keep the heavy bags from swinging obviously inside their pants. The operation ran like a factory assembly line. Diggers underground filled bags. Penguins carried the bags topside. Dispersal teams with rakes covered the evidence. Security lookouts watched for ferrets and guards. If anyone got too close, a warning system shut down the entire operation in 30 seconds. Historical estimates suggest the penguins made at least 25,000 individual dispersal trips during the 11 months of construction. That's roughly 76 trips every single day. 8 pounds of sand per trip. Moving nearly 2 tons of yellow sand per week, scattered in 5-pound increments across the compound. But even this wasn't enough. The winter months brought a new problem. Snow covered the compound from December through March. You couldn't disperse yellow sand onto white snow. It would be instantly visible from the guard towers. So the prisoners adapted. They used Tunnel Dick as a storage facility. Dick's entrance was so well hidden beneath a drain that the Germans never found it. For months, hundreds of tons of sand filled that tunnel's chambers, waiting for spring thaw when dispersal could resume. The engineering department also created false walls in the barracks, hollow spaces between double walls where they could temporarily store sand. Beneath floorboards, inside the roofs, anywhere a ferret wouldn't think to look. But the penguins remained the primary method. Day after day after day. 76 trips. Mixing, raking, covering. And the Germans never caught on.
While the penguins solved the disposal problem, another team faced the challenge of keeping 600 tons of sand from collapsing on top of the diggers. The tunnel dimensions were dictated by the materials available. The prisoners had stolen or liberated thousands of bedboards from their bunks. Each board measured about 2 feet long. This determined the tunnel's cross-section, 2 feet by 2 feet, just barely wide enough for a man to crawl through. At 30 feet deep, Harry passed below the seismograph microphones. But sand is an unstable material. Without proper shoring, a tunnel in sand will collapse within hours. So the prisoners engineered a complete support system. Every 18 inches along the tunnel's length, they installed frames made from stolen bedboards. These frames were reinforced at the corners and braced against the walls. Between frames, they installed wall panels, more bedboards, creating a wooden tube running through the sand. The result? They'd stripped approximately 1,400 bedboards from their bunks. The prisoners slept on bed frames with giant gaps, but the tunnel stayed stable. But beds weren't the only problem. Air was. At the tunnel face, the front where men were actively digging, carbon dioxide accumulated. In a 2-foot square tunnel extending 336 feet, static air would quickly become lethal. The engineering department designed an air pump system built from stolen materials. Kit bags formed the bellows. Hockey sticks and bedboards created the pump handles. They strung together a ventilation pipe from empty metal cans, Klim powdered milk tins from Red Cross parcels, removing the ends and sealing them together with tar. This pipe ran the full length of the tunnel. A 2-man team at the entrance operated the pump continuously, pushing fresh air to the tunnel face. The digger worked alone in a space barely bigger than a coffin. He used a small spade made from scrap metal to hack at the sand face. Behind him, a second man loaded the sand into wooden boxes. These boxes rode on a railway, yes, an underground railway. The prisoners built rails from bedboards and fashioned wheeled trolleys from wooden crates. A rope system allowed pullers at the shaft entrance to haul the sandboxes back while empty boxes rolled forward on the return line. At intervals along the tunnel, they'd excavated halfway houses, slightly larger chambers where men could rest and where the railway system had switching points. This allowed multiple teams to work simultaneously. Lighting came from fat lamps, shallow dishes filled with margarine from Red Cross parcels, with twisted cloth wicks. Later, prisoners stole electrical wire from German work crews and tapped into the camp's power supply. They strung lights through the tunnel using stolen bulbs. The entrance to Harry was a masterpiece of concealment. It sat directly beneath a heating stove in Hut 104. The prisoners rebuilt the concrete base of the stove in removable sections. The stove was always lit, discouraging guards from getting too close to inspect it. Lift the stove, remove the concrete sections. Below was a vertical shaft dropping 30 feet straight down into the earth, with a ladder made from bedboards. German ferrets walked past that stove hundreds of times. They never suspected.
March 24th, 1944, 10:30 p.m. After 11 months of engineering, dispersing 200 tons of sand, and preparing 200 forged documents, Tunnel Harry was ready. The first men dropped into the shaft. The plan called for 1 man emerging from the tunnel exit every minute. At that rate, all 220 escapees would be out by dawn. But engineering rarely survives contact with reality. The tunnel exit came up short, 20 feet short of the tree line. Instead of emerging in the cover of the forest, escapees would surface in the open, in clear view of the guard towers. The plan changed instantly. Runners would have to signal when guards weren't looking. At 1 a.m., an air raid siren blared. The camp's electrical power shut down. Every light in Tunnel Harry went dark. Men sat in complete blackness 30 feet underground, unable to move forward or back, waiting for power restoration. The tunnel system slowed to a crawl. Instead of 1 man per minute, they managed 1 man every 7 to 8 minutes. At 4:45 a.m., 76 men had escaped when a guard literally stumbled over the tunnel exit in the trees. He fired his rifle into the air. Alarm bells rang throughout the camp. The escape was over. Only 76 made it out. 144 never got their chance. But Bushell had achieved his objective. The tunnel worked. The sand disposal worked. The engineering worked. For 11 months, 600 prisoners had moved 200 tons of yellow sand right under German noses without detection. Hitler was furious. Against all Geneva Convention rules, he ordered 50 of the recaptured escapees shot by the Gestapo. Bushell was among them. But the project had succeeded. 76 men got out. 3 made it home. And the Reich had to deploy 70,000 troops and resources to search for the escapees.
The Great Escape wasn't just a prison breakout. It was a masterclass in problem-solving under impossible constraints. Consider what these men accomplished. They moved 200 tons of distinctive yellow sand using cloth bags sewn from underwear. They built a 336-foot tunnel using stolen bedboards. They designed an air pump from hockey sticks. They created an underground railway from wooden crates. They lit their tunnel with fat lamps made from margarine. All while under constant surveillance. All while malnourished. All while knowing that discovery meant death. The engineering principles they used still matter today. When faced with an impossible disposal problem, they distributed it. Instead of one massive dump site, they created 25,000 tiny dispersal points. Modern waste management uses the same principle. Distribute the problem across many small solutions rather than one large one. When material constraints limited their tunnel size, they optimized logistics, the railway system, the halfway houses, the pump system. These turned a 2-foot square tube into an efficient production system. When winter snow stopped dispersal, they used Dick Tunnel as a storage buffer. Modern supply chain management calls this inventory buffering, storing excess until conditions allow for processing. The Penguin system itself was genius. Turn every prisoner into a tiny transportation unit. Make the disposal system so distributed that no single point of failure could shut it down. Roger Bushell created a project management structure. Departments for security, dispersal, engineering, forging, intelligence. 600 men working toward a single goal. And it worked. Today, when engineers face impossible problems, they often look to historical solutions. The Great Escape offers a template. Distribute impossible problems into thousands of possible solutions. Engineer your way around constraints you can't eliminate. Build redundancy into your systems. Never assume a problem is impossible just because it looks impossible. The prisoners of Stalag Luft III proved that determined people with engineering mindset can solve any problem, even moving 200 tons of yellow sand from 30 feet underground without anyone noticing. 76 men escaped that night. 50 were murdered in violation of every rule of war. 3 made it home. But the Tunnel Harry still stands as a testament to human ingenuity. In 2011, archaeologists rediscovered it, preserved exactly as the prisoners left it 70 years ago. The wooden frames, the air pumps, the railway tracks, all still there 30 feet below the Polish soil. A memorial now marks the exit point. It reminds visitors not of war, but of what happens when ordinary people face extraordinary problems and refuse to give up. If you want more stories about engineering solutions that changed history, subscribe to this channel. Next week, we're covering how Allied codebreakers built the machine that cracked the Enigma, using technology the Germans thought was impossible. Drop a comment. What modern engineering problem would you solve using the Penguin approach, distributing impossible problems into thousands of tiny solutions? See you next time.